Welcome to the third lesson in statistics called Class Features. In this lesson, we will determine the class features of a given set of data. These features are class interval, class boundaries, class limits, class midpoint, and class width. We've already talked about grouped and ungrouped data. When working with ungrouped data, the process is straightforward whether we're dealing with continuous or discrete variables. But when we introduced grouped data, some important questions came up. How do we choose intervals? How do we know where to place the values? Now let's answer these by introducing some terms that help us organize data properly. The first term we'll define is class interval. A class interval is a range of values used to group data into smaller, more manageable sections. Think of it like sorting a stack of papers into labeled folders. Each folder, or interval, represents a specific range, making it easier to organize and analyze the data. For example, if we're organizing test scores, we might group them into intervals like 0 to 9, 10 to 19, and so on. This process involves setting class limits and class boundaries, which define each interval clearly. Each interval also has a class width, which is its size, and a class midpoint, the center of the interval, both of which play a role in constructing statistical charts. Next, let's define class limits. Class limits are the smallest and largest in each class interval. Each class interval has two limits, a lower class limit and an upper class limit. For example, in the interval 10 to 19, the lower class limit is 10 and the upper class limit is 19. These values indicate the range of values that belong to each class interval. Class limits are useful when working with discrete data since each value is distinct and falls clearly within a specific class. Class boundaries, on the other hand, help prevent gaps and overlaps when dealing with continuous data, ensuring that each value belongs to only one interval. Think of them as clear dividers that define where one group ends and the next begins, making data analysis more structured and precise. For example, in the class interval 10 to 19, the class boundaries lie halfway between the limits of adjacent intervals. The lower class boundary is halfway between 9 and 10, which is 9.5, and the upper class boundary is halfway between 19 and 20, which is 19.5. We use these boundaries because when rounding to the nearest whole number, values from 9.5 and above are written as 10, while values less than 19.5 are written as 19. However, 19.5 itself belongs to the next interval 20 to 29 because it rounds to 20. This pattern applies to all class intervals. In every case, the lower class boundary is found by averaging the upper limit of the previous class with the lower limit of the current class, and the upper class boundary is found by averaging the upper limit of the current class with the lower limit of the next class. As a rule, values in any class interval follow the relationship lower class boundary less than equal to x less than upper class boundary. This ensures that every value has a unique place in the dataset. Now that we've talked about class limits and class boundaries, let's break down the key differences between them in a way that makes them easier to remember. First, class limits define the smallest and largest value in a class interval. Think of them as fixed points that set the range for each class. These are mainly used for discrete data where each value stands on its own without blending into the next. On the other hand, class boundaries act as the dividing lines between intervals. They ensure a smooth transition from one class to the next, avoiding any gaps or overlaps. These are used when working with continuous data, where values can take on decimals and don't have clear breaks between them. So, how can we remember the difference? Just remember, limits lock in values. They define the exact range for each interval. Boundaries bridge the gaps. They help continuous data flow smoothly from one class to another. That's it. Class limits lock the values in, while class boundaries bridge the gap between the spaces. The class midpoint represents the value at the center of a class interval. It is like the average position of the interval and is calculated using the formula class midpoint is equal to lower class boundary plus upper class boundary divided by 2. The class width tells us how wide each class interval is, which helps ensure our data is grouped consistently. It is calculated using the formula class width equal to upper class boundary minus lower class boundary. Let's look at an example containing discrete data. Given the data below, create a frequency table with 5 class intervals. Then determine the class midpoint and the class width of the first interval. To determine the intervals, we will simply take the lowest value, subtract it from the highest value, and divide by 5. Let's look at another example, this time with continuous data. We will create a frequency table with 4 class intervals. Again, we'll do the same. We'll take the highest value, subtract the lowest value, and then divide by 4. Let's recap what we covered in this lesson. First, we defined class interval, class boundary, and class limits. We then looked at the difference between a class limit and a class boundary, and realized it was mostly due to the data types. Next, we learned how to calculate both the class midpoint and the class width. Finally, we saw how these concepts work together when organizing grouped data. With this in mind, we can move on to the next lesson. That's it for this lesson. In our next lesson, we'll learn how to use this information to create statistical diagrams. Do not forget, you can contact me and look for more resources on the website.